Hello atmospheric science students, Dr. Shragi here, and I'm ready to start showing you how we're going to draw maps on our graphics palette, or our canvas rather, your last assignment was kind of fun, right? You just made pictures using those graphics tools like G-line and so on. Now we're going to actually use databases that describe the coordinates of all the endpoints on a map and so on, as you'll see, to generate maps. It's going to be a lot more interesting, a lot more fun. Alright, so, let's go ahead and, let's go ahead and show you what mine's going to look like. Over here, I just made a simple map. It's got two different databases plotted on here. The yellow lines are the state outlines, and the green outlines are, as it happens, well, it's labeled the continent outlines. In practice, it's also the Great Lakes. It's interesting, actually, you can see how the political boundaries of each of the U.S. states extends into the Great Lakes. I always forget that they do that. Anyway, we have a number of these databases. I happen to plot two of them on this particular plot, but there's rivers and highways and all kinds of stuff, county outlines if you want, and I'll show you how you do all of this stuff. It's kind of a fun thing. So let me bring up our PowerPoint presentation here. So we're going to be learning about drawing maps in this part of the lecture here, and you're going to be getting something that looks, maybe like this one right here, which is a lovely looking map. What is yours going to require? It's going to require knowing your basic graphics commands. In practice, it's just opening a graphics window and drawing lines. That's all these maps are. They involve reading files, because there are going to be databases I'm going to provide you with, where you are going to have all the latitudes and longitudes that describe the boundaries of the states, or the path of rivers, or the path of the interstate highway system, and so on. You're going to have to remember how to use the while statement, and you're going to have to remember how to work with functions. It's been a while since we've done some of these things, so it might take a little bit of review. Alright. There's a whole bunch of these map database files that I have out there. They all have names that end in .ats315.dat. It's because I acquired them from different places and I changed the files so they all worked the same. Four of the more common ones that students like to work with right here are the state.ats315.dat, which is state boundaries. There's also one that has the counties. There's one that has the U.S. interstate system, and there's one that has major rivers. But actually, if you dig around in the directory I'm about to give you, you'll see that there's actually about 20 different databases there of different things you could try, nations and things like that. All of them are in the directory. Oh, I'm sorry that this didn't render quite so well. It's in /home/shruggyj/packages/cgraphics/maps. So this is a folder inside of a folder inside of a folder, but when you get there, there's a whole bunch of these database files that end in .dat. And they are collections of line segments. Every boundary of the United States, like around a state or whatever, is a set of line segments where you could describe each little stretch of that line segment, or every stretch of the interstate, or every stretch of that river as like a latitude, longitude, latitude 1, longitude 1, comma, or whatever, and then to latitude 2, longitude 2. Might be easier if I actually just show you what I'm talking about. Alright, so here I am, I'm logged in as student 315. If I just went over here to home, shruggyj, packages, I hope I have permission here to do this. See graphics, maps. If I go in here, see all these database files here, county, continent, country, roads, interstates, etc. Let's just look at state.ats315.dat. If I just open that up with VI, what you will see here is it's just a bunch of 33,321 lines of a latitude and a longitude, a latitude and a longitude. And these four numbers here, that would be like the coordinates of one endpoint of a line segment, and this is the coordinates of the endpoints of another line segment, and together they make a little piece of a map. I mean, something like Colorado might only have 4 line segments making up each of the 4 sides of it, but something like, Maryland, which has all the little inlets and outlets of Chesapeake Bay, and it might have hundreds of line segments that makes up there. But their latitudes and longitudes, notice the latitudes are positive because we're in the northern hemisphere, and the longitudes are negative because we're in the western hemisphere. 0 is at the prime meridian, and we're working our way left of the 0 axis. So longitudes are negative in the western hemisphere. And there's a whole bunch of these files, and some of them are very, very long. And so what you're going to be doing here, let me just pull this back up here, is you're going to be reading one of these files. And I guess you could go in there with VI and actually see what VI tells you is the number of lines in that file, but that's kind of unsportsmanlike. Rather, we're going to use our while not end of file trick again, where we're going to read in line segment after line segment using file into file. So we're going to have something that looks like this. You're going to have a block in your code someplace where you've opened up a file, I'll call it fmap, and you're going to have said while not end of file fmap. If we're not yet to the end of this database, we're going to scan in from fmap 1, 2, 3, 4 into floating point numbers. I'm calling them latitude 1, longitude 1, lat 2, and long 2, but whatever. And we're going to do something with that information. Alright, so now you have a latitude and a longitude of the beginning and ending points of some line segment. But that's not exactly what C-Graphics needs. C-Graphics doesn't know anything about latitudes and longitudes. What C-Graphics knows about is X and Y. So we have to find a way to transform lats and longs into XY coordinate systems, just a regular Cartesian coordinate system, so that we can get a plot on the screen there. That's what's a little bit tricky. It's a type of interpolation. Now I'm going to talk to you about that right now, but there's also an appendix in the textbook that's about interpolation that will be maybe something that you would find helpful as well. It kind of depends on how much you remember interpolation. See, this map file is full of these latitudes and longitudes that make up the segments of the map, but your graphics window is not really expressed. You can't tell it to plot a point from 40 north, 100 east, 100 west to 41 north, 95 west. The coordinate system doesn't know anything about that. You need to transform that into the XY coordinate system that C-Graphics is using, and these are best done using a pair of functions. What I'm saying here is, like, look at this map I have over here on the left side of the screen here. It's got latitudes and longitudes. And if you think about it, latitude corresponds to the Y direction. The Y coordinates of every point on that map are just a function of the latitude. And the X coordinate of every location on the map is just a function of longitude in this very simple type of map that we're making here. There are fancier map projections that would look better and so on, but we're not doing that this semester here. So let's focus though first on the latitudes. The latitude is what's going to determine the Y coordinate. Okay, if I'm trying to draw a line segment from latitude 1, longitude 1 to latitude 2, longitude 2, which really needs to be x1, y1 to x2, y2, I guess I better know how to change a latitude into a value of y. Well, what we need to do is we need to transform whatever those latitudes are and longitudes to something that's on that unit square, or at least is in that unit square if it's in the region that we want. We haven't yet talked about what region we want, but that's going to be another story. More to the point, you're going to need a function that's going to convert just the part of the map you want to ones and zeros. For example, here on this little map I've got right here, there are clearly latitudes that are available that are outside of my region. I've got a little region here that only goes as far north as like Kansas and so on, and as far south as like Louisiana. Well, obviously the database contains line segments that describe parts of North Dakota. Well, yes, but those latitudes are going to be big numbers, right? Like 50 north or something. They're going to map up to values of y that are greater than 1. Well, that doesn't show up on the drawing canvas anyway, because the top of the drawing canvas is just a 1, so that's going to get cut off anyway. Clearly, though, places like in Arkansas, we want to map to some location that has a value of y between 0 and 1. We're going to be interpolating so that a latitude of, let's just say, 35 corresponds to a place like 0.5 on the y-axis. So that then we are transforming these these latitudes into y coordinates. And I would recommend doing that using a function, which will be called something like transform latitude or whatever. You're going to give it a latitude, and you're going to get back a value of y. You're going to need to know what is the range of latitudes that you're going to be working with. You get to decide that. Define your northernmost latitude. You know, like maybe in this case it's 40 or something like that. And in the you're going to pick your southernmost latitude. And, well, okay, your northernmost latitude, the farthest north you want to show up on that map, that's going to be 1 on the y-axis, right? Because this is a unit square. We're up y equals 1. You get to pick your southernmost latitude as well. Maybe in this case it's about 30 or something like that. And that's going to be the bottom edge of your plot. That might be, you want to map that to y equals 0. Okay? Anything between the northernmost and the southernmost latitude should map to a value of y, should be transformed into a value of y that is somewhere between 0 and 1. Alright, well that's just an interpolation issue. Now I'm kind of giving you, actually, here's a lovely transform latitude function, which would sit on your that calc.c library. Because you're going to use this actually later when we're doing all kinds of things. This is actually going to be a function that's going to get used thousands and thousands of times in every program you run, inside loops and so on. So like, here's a little function. I made a function called transform latitude. The input to the function is a floating point number that I'm calling lat. Okay, I have defined a couple more floating point numbers here, northernmost and southernmost, and another floating point number that is y. We're going to be transforming latitude into y. How are we going to do that? Well, we have to define what we mean by northernmost and southernmost. Those are the latitudes I want to show on my plot. And then that equation there, that y equals, that's interpolation. Again, I'm always a little hesitant to like get too bogged down talking about interpolation unless students have trouble with it. You know, it's the kind of thing you like rocked at in like 7th grade and probably did pretty well in high school, and then, you know, in college you almost never do interpolation. So like I said, I've got that appendix in there. But if you need help with interpolation, I'll be glad to help you. We've got lots of interpolation to go yet this semester. But y then maps to a value between 0 and 1 if the value of latitude is between northernmost and southernmost, and then we just return y. So that's what this function is going to do. It's going to change your value of latitude into a value of y. So like, for example, I could go back in my main program here. I could have a while. It's not the end of the file. We're going to read in the next 4 values of lat1, lon1, lat2, lon2. That latitude 1 is going to get transformed into y1. And that latitude 2 is going to get transformed into y2. And then we could do the same sort of thing with longitudes as well. You're going to have to write a slightly different function that knows about the easternmost and westernmost limits of your region. And you're going to transform the longitude 1 into a value x1, based on the easternmost and westernmost longitudes that you're trying to show, and do the same thing for lon 2. Lon 2 gets transformed into a value of x, x2. So now you have an x1 and a y1 and an x2 and a y2. Well, guess what you do with that? You draw it. I mean, you just G-line that thing. There is no specific assignment in this lecture here. You just do have to draw a map, because there's no particular reason for me to make you like turn in this map right now, because you're going to make a few small changes in the next assignment and then turn that in instead. But obviously you're probably going to encounter challenges working on this, and then you're going to be able to submit this here. But this is actually pretty cool. Now I want to just kind of give you a little sense here about one of the things you can do with this. Again, looking at my set of plots here, hold on. If I just bring my map up right here, notice I actually have 2 different databases going on here. Look what I actually did. I'm going to try to show you really quick in my assignment 11.c program here, without giving everything away. Notice what I did here. I opened my state.ats315.dat. I set the attributes to be, I think this is a yellow line. And I did exactly what we just showed before. Look, I read in, while not end of file map, I read in the 4 integers, lat1, I'm sorry, the 4 floating point numbers, lat1, lon1, lat2, lon2. Did a transform longitude, transform latitude, transform longitude, transform latitude. Now I have x1, y1, x2, and y2. And I just drew it. Okay? And then when I was done with this loop, when I had reached the end of file, I just close it up. Close up that loop. Once I had that working, all I did is I just literally cut and paste that code in a second time, except instead of using the state database, I used continent database, cont.ats315. That's what has lakes and things like that in it, as well as the continental outlines. I set the color to a different one. I think this is green if I remember right, but this code is all exactly the same. I just cut and pasted it in there, okay? I can show you how to cut and paste if you want to see that at some point. It depends on whether you're on a Mac or a PC or whatever as to how exactly to do that. Alright, I could have kept doing this and drawn more and more stuff on my map. Heavens. Let's actually do that. Just for sake of argument, let's put in the county database. Alright, I'm going to cut in here. I'm just going to break my little program here. I'm going to go ahead and put this, oops, right here. And I have to admit I don't remember what the continent database is called, so I'm going to open up a terminal here and go get that real quick. I don't know that you can read what I'm saying here, but I'm just going into that packages, C graphics, maps. Again, I recognize the font is probably too small here, but the county databases are CNTY. Okay, so where I have that this is the continent database here. It needs to be CNTY. Alright, so here I am. I opened up the county database. I am setting the line attributes apparently still to green, which is fine. And I'm just doing exactly the same thing. I'm reading every line of the county database. How many lines are there in the county database? 44,000, some of them. It takes 44,000 some line segments to draw the counties in the United States. And we're going to save that. I'm going to compile it. Oops. There we go. Graph. Oh, I misspelled GraphCC. There we go. GraphCC assignment 11.c. And I run it again. And whoa, look at that. All those counties on there as well. Pretty cool, huh? You're going to make maps that are little Technicolor disasters like this. We'll learn how to make maps that look a little bit more professional as time goes by, but for now, feel free to play with funny colors and all that kind of stuff and make this look pretty cool. Students have definitely done a lot of really creative things with this assignment over the semesters, but that's not necessary. Just get this up and working. If you want to send it to me at some point, that'd be great for me to see what's all going on. Odds are you're going to have some challenges. But we'll get this working, okay? This is a particularly interesting program because once we get this working, you can see how we're going to use these same tools like transform latitude, transform longitude to do things like plot weather data. Once we know a state, Omaha has a certain temperature, we're going to use another database to find out where is KOMA. Oh, it's at this latitude and longitude. We're going to use our transform latitude and longitude functions to figure out where X, Y that is on the screen. And then we will use gprintf to print the temperature at that location. Oh my gosh, I practically told you how to do that assignment now. Darn it. Anyway, alright, you have all the tools that you need to make this work. I'm excited for you. Please let me know how it goes. I'm always interested in seeing how students do this and stuff. Please let me know how it all works. This has been Dr. John Schrage.